Okay, so because acetylcholine is so, important in the peripheral nervous system, both at the neuromuscular junction, right, and also in the autonomic nervous system, many toxins, actually, it turns out, will act at peripheral nervous system cholinergic receptors, actually, and they don't even need to cross the blood-brain barrier to have rather toxic and often even fatal effects. One example are the botulism toxins, which are proteins produced by the botulinum bacteria. This is the kind of thing you're always warned about if you get canned food, right, and the top of the can is popped up. These are bacteria that can live live without oxygen inside, a can of food, and they will generate these toxins, and these are quite potent. They can basically inhibit the release of acetylcholine, and they can prevent, damage the neurons that will go to the diaphragm, for example, and permit you to breathe. So you can asphyxiate with exposure to these toxins. There's also these toxins that are used clinically. They're the same, proteins that damage and inhibit the release of acetylcholine. They physically damage the motor neurons that go to the muscles. They're called clinically, they're referred to as Botox. They are injected sometimes for good clinical uses, right? I mean, sometimes people have muscles that are too contracted. Maybe an eye is pulled too far to one side and they need to relax the muscle. So they can pull back some of the motor innervation of that muscle. Or there may be some of the muscles of the larynx and pharynx that are too tight and overly stimulated. And it leads to a strained voice. So they can inject these toxins which will damage that neuromuscular junction and relax the muscle. And it can help to solve the problem with speech. This is also, of course, used to relax muscles that give you a frown line, right? Or to give you rather wrinkles on your face. You're using rather potent toxins that specifically damage acetylcholine synapses, right? It turns out that black widow spider venom is another compound, chemical, that ends up promoting massive release of acetylcholine. And it turns out that when there's a lot of acetylcholine that's released at a synapse, like in the periphery, right, at the neuromuscular junction, let's say, there's massive stimulation of those postsynaptic receptors. And they respond in a very interesting way. They will initially open, right? These are a lot of the ionotropic receptors that you find, right, of the muscle. And they'll allow for sodium to come through. But if they're overstimulated, they actually shift into another form where they cannot be activated by acetylcholine anymore. They become what we refer to as desensitized. So you need a certain level of activity at a synapse, like the neuromuscular junction, to open the channel and allow for contraction. But if you overstimulate, it'll open a lot and then it'll close, and it'll close rather permanently. I mean, it'll take a while for it to reopen. It's desensitized. So this massive release of acetylcholine overstimulates these receptors. There's a lot of response at first, and then there's no response. So your diaphragm stops responding to release of acetylcholine. Other muscles stop responding, so you can asphyxiate and die with exposure to this venom. It's a large amounts of it. There are also other plant poisons like curare, for example, which is an antagonist at the neuromuscular junction receptors. So if you think about our acetylcholine synapse, right, on the muscle, there are these receptors that are set up, like these ionotropic receptors, that are going to bind acetylcholine, shift and open, and depolarize the muscle and promote contraction. Well, curare sticks on that receptor. It's an antagonist, right? It'll prevent it from opening. It'll prevent the acetylcholine that you're sending, desperately, to contract the diaphragm to breathe. It'll prevent it, from opening. So it can also promote death. This is actually a poison that certain cultures actually would dip arrows in and then shoot at a game that they were hunting to paralyze and to kill. So many toxins actually act peripherally at these acetylcholine receptors.